Video problem number 25. The topic is the mole. We're going to be using Avogadro's number here. Let me just remind you what that is. So Avogadro's number says that there are 6.022 times 10 to the 23rd particles, whatever that is, per 1 mole. Okay, so let's go ahead and use that as a conversion factor here. Determine the number of molecules in quotes here because we have an ionic compound. Ionic compounds technically which should say determine the number of formula units, but we just use molecules. We have 0.075 moles of sodium bicarbonate, NaHCO3, and we want to figure out how many molecules we have. Well, I'm counting molecules as it is, right? It's just I have it in moles. So I'm going to put moles on bottom. So that cancels out. I'm going to put molecules on top. And so that takes the place. And so I have 6.022 times 10 to the 23rd molecules in 1 mole. Now make sure you take out your calculator and try this with me here. So don't forget you want to use the EE button. And I get a value of, let's see, how many sig figs? 2. So I get a value of 4.5 times 10 to the 22nd molecules of NaHCO3. Right. Let's try this number 2. It's a little bit different. Determine the number of atoms of oxygen in 1.32 moles of calcium phosphate. So first let's write the formula for calcium phosphate. Calcium is positive 2. Looks like that. Phosphate, hopefully you have it memorized. PO4, negative 3. Right? So I need 3 calciums and I need 2 phosphates. So there's my formula. Now, I have 1.32 moles of this compound, Ca3PO42. And the question is, how do I get to atoms of oxygen? This currently is not counting atoms of oxygen. So the first thing I'd probably want to do, you can do this a couple different ways. What I'm going to do is I'm going to take it from moles of calcium phosphate to moles of oxygen. So let's do that first, right? So let's see. I want to get rid of calcium phosphate, Ca3, PO4, 2, and in its place, so now that cancels out, in its place I want oxygen, right? So how many calcium phosphates per oxygen? Well, for every 1 calcium phosphate, I get 8 oxygens because it's 2 times 4. Right? So that'll get me moles of oxygen. So 1.32 times 8, that gives me 10.56 moles of oxygen. Don't round yet because we're not done. I want to know atoms of oxygen. So I'm going to take that 10.56 and I'm going to convert that to atoms. All right? So let's see. I want to get rid of moles. I want atoms to take its place. So moles cancel out. So for every 1 mole, there are 6.022 times 10 to the 23rd atoms. So I want to take my 10.56, I want to multiply by 6.022 times 10 to the 23rd. And I get a value of how many sig figs? 3 sig figs this time. So I get a value of 6.36 times 10 to the 24th atoms of oxygen. Now I said there's more than one way to do this problem. Let me show you the other way to do this problem here. All right, we're going to start out again with 1.32 moles of Ca3PO42. Maybe you thought of a different way to do this. So a different way you can do this is now we can go from moles of calcium phosphate to molecules of calcium phosphate. Right? So I can say, let's see, here's moles on bottom, here's molecules on top. Right? So moles cancel out. The molecules. For every 1 mole, there are 6.022 times 10 to the 23rd molecules. So now I'm going to take 1.32 times 6.022 times 10 to the 23rd, and I get a value of 7.949, don't round it yet, times 10 to the 23rd, and that's going to be molecules of calcium phosphate, Ca3PO4 2. But that, I want to get atoms of oxygen. So I'm going to take my 7.949, my number that I have stored in my calculator, times 10 to the 23rd. And that is molecules of calcium phosphate, Ca3PO4 2. And now I'm going to get rid of molecules, and I'm going to pick up atoms of oxygen, right? So this should be molecules of Ca3PO4 2, because I want that to cancel out too. So for every one molecule, there are 8 atoms of oxygen. So I'm going to take my value that I have in my calculator, I'm going to multiply it by 8, and I get a value of, oh thank goodness it's the same answer, I get a value of 6.36 times 10 to the 24th, and that's atoms, ooh, come on, behave, that's atoms of oxygen. Alright, so same answer as before, and it should be, right? Just 2 different ways to do the same problem. There you go, video problem 25.